So everybody, we have this triangle, PQR, with sides PQR, right, with their opposites. So if I say the sine of angle P, I stand on P, opposite over hypotenuse. So guys, this is P over Q, or no, yeah, P over Q, right? It's a fraction. Done, that's the answer. Guys, cosine of P is the adjacent over the hypotenuse. How about R over Q? All right, now I'm on tangent of P, right, which is opposite over adjacent, P over R. All right, everybody, listen carefully. I really want your focus here. You don't need the triangles once you have these three ratios to do these three. All right, this is a big step for us. We know these three ratios, and we know angle P and angle R are complementary. They sum to 90. And once you know that fact, we have a lot of ways to handle these other three ratios. We know that the cosine of P and the sine of R will be equal. Look at your table if you set it up the same way. This has to be R over Q. So I have P over Q here. That means that cosine has to be P over Q. All right? So what that means, everybody, if I write sine of 20 degrees, what's equivalent to it? Cosine of 70. Done. If they are complementary, right? And that's what we just showed here because P and Q, all right? That's what the numbers look like. The last thing, guys, what's the relationship between tan R and tan P? They are reciprocals. This is just R over P. All right. We got one problem. We got these six ratios. What letter is never on top? Q. Gosh, you know what? I really want Q to be on top. In fact, I want a ratio that's Q over P. Do you guys agree that that's the reciprocal of sine P? And everybody, before you start throwing out ideas, we really can't write this, can we? That would be a negative exponent because there's a huge problem with that. We already have that button in our calculator, right? That's not 1 over sine. That's saying, hey, give me a ratio, give me an angle. So we can't use that notation. All right, can't use that notation. All right, well, all right, so that means we could write it as, you guys agree this is 1 over sine P, the reciprocal? Right? That's right, okay? But here's the problem. Guys, you think a mathematician's going to live with this? No. So a mathematician's going to look at this and say, hey, gosh, you know what would make this really confusing? Let's start this with a C. How about cosecant P? CSC P. Cosecant. Instead of calling, and that'll be the reciprocal of sine. Well, then the next one down is Q over R, right? We know that's 1 over cosine. Well, you know what would make this super confusing? What letter should we start this trig name with instead? Let's start this one with S. Let's call it secant. If you're wondering why, it's not to confuse you. It's from the Latin. But it sure is confusing, right? And everybody, the only one that makes any sense in the name, if you have tangent P and you want to do the reciprocal and divide by tangent, right? So it's R over P. We call it cotangent. So this is cosecant, CSC. This is secant, and this is cotangent. These are all your trig functions. When you took geometry, we only did 3. You got sold half a bill of goods. These are the rest of the ratios that can be wrote out from an angle. Everybody, we do this because we don't want books to be 2,000 pages long. Right? We don't want fractions where we can write a simple word. And it's reciprocal trig is what we call it because it's the reciprocal of these 3. So if we do an example, let's erase these. So we learned about the relationships. We'll talk more about complementary relationships next time. Next week, all right? We'll start making those statements. Everybody, my favorite triangle. 3, 4, 5. Let's have A, B, C. Let's just do 2. Let's do secant of A equals, and let's do cotangent of B equals. All right, everybody, the first thing I personally do is, what is secant? Secant is the reciprocal of what? Cosine. Guys, I don't try to figure it out. I do the cosine of that triangle. So everybody, if I'm looking at secant A, what's cosine of A? What is cosine of A of this triangle? 3 over 5. So guys, what's the reciprocal of 3/5? The answer is 5/3. The answer is 5/3. Done. Guys, I don't try to find the cotangent of B. Cotangent is the reciprocal of tangent. Guys, find tangent first. Find tangent of B for me and see if you can get cotangent. You should be able to write it, right? So I'm looking here. And again, I tend to write them. Guys, I pick a spot up here out of the way. Tangent of B, opposite over adjacent. How about 3/4? So the reciprocal of 3/4, everybody? 4/3. Congratulations, you just did reciprocal trig. All right? Everybody, you don't have to memorize this. You know why? I'm going to write them up on the board either end of the day or tomorrow. This won't be on any quizzes or anything soon. And every time you need to look, you'll be able to look back and pick this relationship up. Okay? So you know what the reciprocals are. And we're going to use them so much that in a month and a half, you'll just know them. At some point, I'll be like, can I erase them? And everybody will be like, okay. All right? You're just going to know them. Reciprocal trig. Reciprocal trig. This is it, though. Congratulations. There was only 6, and we've done it. Okay? There's 6. We've done them all. All right. I want to talk about one other thing today. And then let's see if we can get to we should be able to look at the board and name the type of function this is from our mothers, right? So when you look at the f of x, guys, what name is this? What kind of thing is this? Huh? Linear, line, I'll take it, right? This is a line, linear, both right. Anybody remember this is what this is called? Parabola. There we go. Awesome. So, what do you think happens if I give you notation? What do you think is going to be the answer if I write this? Anybody want to take a stab in the dark? Anybody? Hush falls in the crowd. Would it surprise you that it's 3x plus 2 plus x squared? 3x plus 2 plus x squared? There's f of x, and then this plus sign is going to be here. And there is g of x. That's all it is. Anybody want to hazard a guess what this is going to be then? F plus g of x. How about the same thing? Oh, wait a minute. How about this? F plus g of x. Anybody want to hazard a guess on this? Same thing. And everyone, this is what I'm talking about, math. We have to be familiar with all 3 notations. These all mean the exact same thing. Okay? So when we start doing functions, right? And again, it doesn't matter which one goes first. 1 plus 2 is 3. 2 plus 1 is 3. So do you guys all agree that I could have written g of x plus f of x? Right? I could have written g plus f of x or g plus f of x. You notice I say them all the same way. Alright? Everybody, they're all the same. What wouldn't be the same? If addition's the same, would subtraction be the same? No, 2 minus 1 is 1. 1 minus 2 is negative 1. So when we start doing these functions, it'll become important. So if I write, let's do g of x minus f of x. This is one that usually we get wrong by chance. I'm going to put it up here. So you take g of x, and everybody, when you minus f of x, the negative has to distribute. It's negative 3x minus 2. Everybody, we are going to do a ton of practice on this next week. Just globs of it. Ugh. Because it's just so important with what we're doing. And we can do multiplication and division. Okay, we can do multiplication and division. And we can do other things too. But we're going to start with our 4 basic operations. Addition, subtraction, multiplication, division. Okay? This is called composite functions. And we're going to do just a ton of this next week. And the big thing here is understanding that the notation is not common. Right? There are a bunch of ways to write it. And we have to learn to read it all the possible ways. And I'll try to make sure I do them equally. And you notice, guys, on day 1, I'm a big believer in this. Day 1, I don't show you the one way, right? I don't write one of these. I write all of them. Because we have to see them all that way. All right. I have another thing, or is that it? Oh, next week, guys, we're going to go back to completing the square. I'm going to treat it like you've never done it. After talking to a few students about it, we're going to start completing the square like you've never done it. I know you did a little bit in Algebra 2, okay? We're going to talk about it as a factoring. I answered a question for a student on fractional exponents. Do you guys know why the square root of turns into the half power? Somebody probably goes, I don't care, Anderson. I don't care. You do care. Guys, we are peasants. We cannot make math just because we want to. Right? So everybody, we know 3 squared is 9. So you're over here. Everybody, do you guys agree that's 3 to the 1 power? Do you guys agree 9 is 3 to the 2 power? Everyone, you cannot just change a 2 into a 1 because there's a radical there. The math has to work with all our rules. So if you change this to an exponent, what exponent do I have to put here? 2 times what gives you 1? Hey, Carter, bear with me, man. Guys, I want to do one more because I want you to see this. Guys, you can't just change 8 into 2 to the 1. Do you guys agree that 8 is 2 cubed? So again, the math has to work. It has to. We're peasants. Guys, it has to be a third because 3 times a third is 1. This is why. So the opposite of multiplication is division, subtraction. And guys, not square root, just a root, because sometimes it's a third root, sometimes it's a fourth root, sometimes it's a fifth root. Depends on what the exponent power was. Everybody, that's enough for today. Assessment tomorrow. Bye, YouTube.